Okay, now we have come again with this interesting topic on the board, which is forces in equilibrium. Now, you know that this is part of the branch of mechanics called what? Statics. You know, mechanics is the science of force. It's a branch of physics that deals with force and its effect on bodies. So it consists of two branches. That is, we have one, dynamics. We have number two, statics. Statics. So this topic, forces in equilibrium, is inside this. That is under this statics. This is the branch of mechanics that deals with it. Okay. So now let us first of all define or say what it means for a body to be in a state of equilibrium. Now, a body is said to be in a state of equilibrium if condition one, the resultant force on the body is equal to 0. That is, the resultant force R is equal to what? 0. This is the first condition. Condition two, the algebraic sum of the moments about any point on the body is what? 0. Now, these are the two conditions that will be satisfied for a body to be in a state of what? Equilibrium. You can say the algebraic sum of the torque or moment, torque, T-O-R-Q-U-E, this is torque. So this thing means the turning effect of a force. Do you understand? This is what it means, torque. So now it has the same definition with moment. Moment of a force is product of force and the perpendicular distance. That is what moment of a force is. So now let us digest these two conditions. First of all, they say the resultant force is 0. This is the expression of the resultant force. R is equal to Fx squared plus what? Fy squared. Now, if the resultant force is 0, it means that Fx is equal to 0 and also Fy is equal to 0. That is the sum of all the horizontal components of the forces on that body, acting on that body or that system, is what? 0. Also, the sum of the vertical components of the forces acting on that body or that system is equal to what? 0. Do you understand? So if this thing happens, it means that R is equal to square root of 0 squared plus what? 0 squared. We have R is equal to what? 0. You see? So this is from the first condition. You know that force is a vector. So every force has what? Both horizontal component and what? Vertical component. Do you understand? It has both horizontal component and vertical. This is horizontal component. This is what? Vertical component. Now let us move over to condition 2, the second condition. Now, to explain the second condition, let's have maybe a meter rule resting on a pivot support, on a support like this. So let's say this force is F1. Let's say the distance is X1. This one is F2. Let's say the distance is X2. Let's say there is another force here. Let's say this is F3, the distance X3, this one, let's say there is another force here. Let's say F4, and the distance is what? X4. Now, from the second condition, they say the algebraic sum of the moments of the forces about any point, this is the point on the body, is what? 0. Now, this we consider like this is clockwise forces. Like clockwise forces are 1, 2, because this force is going like this, clockwise, while this one is going like this, anti-clockwise. Do you understand? So clockwise moments is equal to what? Anti-clockwise moments. Do you understand? So we have clockwise moment is which is F2 times X2, then plus plus F3 times X3 equals to anticlockwise moment equal to F1 times X1 plus F4 times X4. Okay. So now we sum like we bring the right hand side to the left. So we now have F2 times X2 plus F3 times X3 minus F1 times X1 minus F4 times what? X4 equal to 0. So this is from the second condition, that the algebraic sum of the moments about any point on the body is equal to what? 0. So for a body to be in a state of equilibrium, these two conditions must be satisfied. So now that you have understood what it means by a body to be in a state of equilibrium, my next video will be questions on this. Okay? So get ready.